One of the most important aspects of data visualization are the various data dimensions. Let's look at these a little bit. You can have univariate data or data that has a single dimension. If you can see that what I've been given is age and of a number of passengers, and I have plotted a frequency of this and created a sort of a histogram here. Then you can have bivariate data when you've got at least two factors, and these two factors or features are being plotted in this graph over here. So on one axis or one column, I've got one feature, and on the other axis, I've got the other feature. I've got fare over here and age over here. Then you can have trivariate data or three dimensions of data. We have age and fare and class. So if your fare was this, maybe you were in the third class or you were in the first class. Okay, these are like the train classes that we have. One thing that we need to note over here is that there is no point in using 3D scatter plots. So if I plot all of this data in three different dimensions, there's not much information that I'm extracting at all. It is rather more useful to map the third dimension to some visual attributes. So now I have this first class, second class, third, and I'm using this as more of labels than a unique feature in itself. I've created this, used this as if this was the label or the product of these two age and fare. Now I can better visualize that what amount of or what percentage of fare was in the first class and in the second class. And this is giving me a lot more useful information than the previous chart. And when lastly, we can have multivariate data. Multivariate means that when we can have any number of dimensions. But please remember over here that as human beings, we cannot visualize or see anything that is beyond three-dimensional. Our real-world system is also three-dimensional, and that's the best that we can do. So what the solution that we come up is that we assign different attributes to different color. We can have different color codes, or we can modify these into simpler or smaller dimensions. That's what we did previously in dimensionality reduction as well, that we can map the higher dimensions into smaller dimension in order to have a better visualization. So data reduction can be through filtering. It can be through aggregation. Filtering means that we are eliminating some items or attributes either through selection or extraction. For example, select a range of interests, zoom in, remove outliers, so on and so forth. And aggregation means that we represent a group of elements by derived elements. So we see some similarity between a number of features, and instead of using those features as individual ones, we group them into one feature. So again, we end up with a lesser number of features than the one that we began with. So we use aggregation or grouping. For example, we can take averages, min, max, or count. We can attribute aggregation, for example, just as we have in dimensionality reduction. There are numerous graph types that are optimized for the type of different types of information. If you look at these over here, you see that in case you want to show distribution of data, you can create a column histogram, you can have a line histogram, you can have scatter charts or 3D area charts. Similarly, if you were to represent the composition, you can have a pie chart or waterfall chart or standard area chart. And similarly, a stacked chart, stacked would again give a very clear or very nice composition of different elements belonging to different classes. Then in order to represent relationship, we can have scatter charts or bubble charts. Scatter charts are best for two variables, and anything beyond that, for example, three variables, that's more suited for bubble charts. Then for comparative analysis, we have a whole range of visualizations again, such as bar charts, column charts, table or table with embedded charts. All of these represent multiple items. but column charts are more suited to few items rather than many. If you've got two items or two variables per item, you can use the column charts in those scenarios. Then we can have circular area charts or line charts. The line charts are non-cyclic data. Any sort of linear relationship can be represented with them. And if you've got multiple categories, you can use these multiple line charts. So there is a whole bunch of these charts or types that you can use based on whatever your need is. So different needs lead to different types of charts that we create.